I want to thank everybody for joining us today. So welcome to this session. This is FWM310, how to build an AI gateway for Amazon Bedrock with AWS AppSync. Now, I think it may come to no surprise here for people in the crowd and the audience that generative AI is everywhere these days. And we are seeing more and more customers adopt this technology and looking to take advantage of it. That comes to no surprise. But as customers are getting into generative AI, there are a lot of challenges that they are facing, specifically trying to connect their application to their generative AI backend. So what we're going to do in this presentation is talk about AI gateways and how AI gateways can make a real difference when it comes to connecting your applications to your generative AI backend and to your AWS Bedrock models. My name is Brice Pelle, and I'm a Principal Product Manager at AWS AppSync. I am joined today by my partners, Salman Mogul, who is a Principal Consultant at AWS, as well as Cal Rube from Applied AI at Anthropic. Our agenda today. We are going to cover three general areas. First, we are going to talk about AWS AppSync as an AI gateway and how it can help you connect to Amazon Bedrock. Then we are really going to deep dive into some actual enterprise integrations that show you how you can leverage AppSync today in your own application as an AI gateway. And then finally, we're going to dive deep into some common challenges that you may face as you start to build your own applications that leverage LLMs. All right, so as I mentioned, things are moving really quickly, generative AI everywhere. But even though things are moving quickly, we're still into early days, and customers have a lot of questions. Customers want to get started, but they are asking AWS, which model should I use? How can I move quickly? How can I test my models? How do I deal with security? How do I keep my data secure? And because they've been asking us all of these questions, AWS built Amazon Bedrock. And Amazon Bedrock is really a game changer when it comes to how you connect to models. It is the fastest and simplest way to connect to models, to test models, to build application, to test your prompts, to build RAG, and to connect to agents. It really just changes the way you go about connecting and interacting with LLMs. Yet, there's still some challenges that remain, specifically when you talk about connecting your own application to your generative AI backend. Customers face a couple of challenges. The first one is connecting to their backend itself. Customers need flexible security and access control in order to connect their application to their backend. They need an API solution that is going to provide the required and necessary authorization modes that will allow authorized users to interact with their models. If your model is your IP, you want to control access to those models, you want to control access to those prompts, and you want to make sure that only verified users have access to those things. You also want to make sure that you can decouple your front-end access patterns from your back-end access patterns. You want to make sure that you do not expose your private credentials to credentials that you potentially use to access your own generative AI backend in your front end. And you want to make sure that you can use the right authorization modes for your specific API, for your specific application. Different applications may have different requirements, and you need to be able to address that. Secondly, you need flexible request handling. Now, with generative AI, requests can be short and requests can be long-lived. You need an API solution that is going to allow you to do synchronous access, synchronous invocations on your models, as well as support long-running invocations. These are invocations that can take 30 seconds to 5 minutes, and you need an API that's going to enable you to deal with that. You also need to have an API that is going to allow you to send progressive updates to your applications in real time without requiring your applications to continuously poll for data. And you need a solution that is going to work with a variety of applications, whether those be mobile applications, web applications, and IoT applications. And then finally, you need a solution that is going to allow you to have flexibility when it comes to your model selections. You want to be able to provide an API that is going to let your applications connect, but that is also going to protect your models, protect your prompt, protect your intellectual property, your business logic, and at the same time allow you to swap out your model without necessarily having to swap out your API. So builders need flexible API solution to connect to their generative backend. And this is where AWS AppSync comes in as an AI gateway. Given all of these challenges, one of the things that we've seen over the last couple of months is AppSync evolving into an AI gateway for many of our customers. And there's a couple of reasons for that. AppSync allows you to connect securely and converse with your Amazon Bedrock backend. It allows you to do real-time solutions for long-running workloads with its native WebSocket offering over subscriptions. You can keep control over your users and your model access, and you can control those separately. You can create objects that get you the data you want by using Graphql built-in type capability. And then at the end of the day, you can decouple your apps from your models, allowing your models to grow at their own speed and allowing your front-end application developers to keep their own velocity. So, show of hands here, how many people are familiar with Graphql?
Oh.
Wow, okay, we've come a long way. A lot of people in the audience familiar with Graphql. But for those that are not super familiar with Graphql, just to reset a little bit, what is Graphql? So Graphql is a query language for your API. It allows you to specify fully typed documents that tell you how your API is supposed to behave. It allows clients to make requests to your APIs that access multiple data sources without having to make these multiple requests that you would typically see when using REST APIs. One of the key things here is that it allows you to avoid overfetching because clients can specify exactly what they want. And then your backend will then connect to the data sources that are required to fetch data. So GraphQL is pretty powerful. And one of the things that AppSync provides as well is real-time capabilities with subscriptions. AppSync allows you to forward real-time events to your applications over managed WebSockets using GraphQL's subscription capabilities. And this opens up a whole range of possibilities when it comes to building long-running applications that need to connect to a backend and that are going to take minutes to get you an answer back. With AppSync, you get authorization types out of the box. You can use a multitude of authorization type and use the proper authorization type for your applications. This is all included in AppSync, and there's really nothing that you need to build to do this. You can use Amazon Cognito if you want to authorize individual users and be able to track their identity throughout their request. In development, you can use API keys, or you can also use API keys for semi-public access patterns in your API. Many of our customers are choosing to use Lambda authorizers to build their own custom authorization. The key thing here is that you can use the authorization modes that is best suited for your application, and notice that you do not need to expose any of your backend credentials in your applications. So you decouple your front-end application authorization pattern from your backend permissions. On the backend side, AppSync integrates with generative AI backends by allowing you to directly interact with your models. And you can do this by creating a data source. AppSync allows you to interact with Amazon Bedrock via integrated data source. So you can create an Amazon Bedrock runtime data source, or you can use an AWS Lambda function as an orchestrator that you can then use to invoke your model. And this is pretty useful when you want to create applications that require orchestrations that are going to take a long time to respond. You can also use our native HTTP resolvers and HTTP data sources. One of the things that you may not be aware of is that you can use our HTTP data source to connect to any AWS service API. And all of these data sources have their own authorization configuration. So you can enable AppSync and you can authorize AppSync to talk to specific models, to interact with specific prompts, and to have access to specific guardrails when you configure your data source. This is how you construct a security around access. So you configure how AppSync can interact with your Bedrock backend, and then separately, as an API administrator, you can configure how your users are allowed to interact with your API. When you take those two things together, you can then create purpose-built APIs that are built specifically for the applications and for the use cases that you are trying to implement. Another great thing about AppSync is that it provides security features, enterprise-grade security features. So you can use things like private APIs. We have a lot of customers today that are building generative AI solutions that are only meant to be used internally by their internal staff and users. With private APIs, you can create APIs that are only accessible via inside your internal VPC. And with our new private GraphQL API feature for cross-accounts, you can now create APIs in one AWS account and share them with any AWS account in your organization. This is great for organizations that use multiple accounts to create separations of concerns. So you can have one central networking account that creates your API and then shares those APIs with the rest of the organization. Connecting to AppSync, to your Bedrock backend with AppSync is super easy. As I talked about, you can use an HTTP resolver. You can also use our new integration with our Bedrock runtime for simpler integration with micro invocations. This is when you need to do an invocation that is going to take up to 10 seconds or less. You can use our invoke model or converse API. So here I have an example of an API that is requesting, that is creating an assistant query. And the assistant query is going to take a natural query language and then make a request to the Converse API to get a SQL query that is the equivalent of what I'm asking it. I can then map my types to a JSON schema. And then when I call the Converse API from my resolver, this is the exact same API that you will find in our AWS SDKs. And I can call it directly from my resolver. I can leverage everything that you know about Bedrock, and one of the things that I love about this is that I can also use the guardrail configurations to further protect my invocations. So if I want to protect this from prompt injections, or if I want to stop Bedrock from returning sensitive information, I can use guardrails for that. And then you can see an example of what this will do. I call my query with my assistant and I tell it, give me the most sold items shipped to the city of Las Vegas. And I also tell it, explain your answer. Now, if I had given it a system configuration and the database schema that you see here, this is the type of query that it would have returned to me. Notice that it's returning to answer in a specific shape. And this is super useful because when I return this to my clients know what to expect. They know how to handle the response. And so there's very little work that you have to do at your client. You can keep all of the logic inside your API. I can also use the invoke model API. For example, if I wanted to invoke Amazon Titan, I can do this to create some summarizations and a list of key points. I can use Amazon Titan embed text to also create embeddings. This is super useful if I want to do something like create an API to do similarity search. For example, I can use this in collaboration with our pipeline resolvers, where in a first step, I'm going to use Amazon Bedrock to create an embedding. And then I'm going to use the result of that embedding to search for data inside my Amazon Aurora database, Postgres database, using that embedding. This is super easy to do. You do not need to configure any additional computational resources, and you can do this entirely within AppSync without exposing any of your prompts and models to your client. Last but not least, there's the asynchronous use case. And these are the use cases that you are going to use for long-running invocations. You can enable this with AppSync as an AI gateway by using AppSync subscription capabilities. In this example, you see that I'm calling a Lambda function. The Lambda function here serves as an orchestrator that calls the Amazon Bedrock backend. When Lambda receives the updates from Bedrock, it can then send those updates to my AppSync API using a mutation. And AppSync will automatically forward those notifications to my connected clients. This allows me to send progressive updates to my client as I receive those notifications. And we are seeing a ton of these patterns being implemented by our customers today. To dive more into this, I'm going to invite my partner Salman to the stage to tell you more about enterprise integrations using AppSync AI Gateway.
Yeah. Hi, everyone. Hope everybody can hear me okay. Excellent. So I'm going to talk about two use cases that we've seen our enterprise customer kind of deal with and challenges. One is around content analysis using large language models, and leveraging AppSync as a gateway to kind of get to those models. The second use case talks a little bit more about contact center and how we used Amazon Connect. Kind of show of hands, how many people know Amazon Connect? Excellent. So I think this use case will be very interesting for you guys. So there are some inherent problems with Amazon Connect and how we used long-running workflows to kind of leverage and break that 8-second barrier. My name is Salman Mughal. I'm a principal consultant with AWS Professional Services Canada. Lately, since this whole generative AI craze started last year, I've been solely working on some of the enterprise customers and kind of solutioning some of these use cases. So a little bit first where asynchronous pattern is very useful in a modern day applications when you need to kind of push real-time updates to your front end. AppSync is your best friend. Notifications are the best way to kind of use AppSync under the cover. When you're interacting with long-running tasks, it becomes even more important when you're using, for example, generative AI capability. I'm sure everybody has used Bedrock and chat playgrounds, and you see all those tokens being kind of streamed. Behind the scene, there are Bedrock APIs that are being invoked, so we'll kind of dive into that area a little bit more. The two use cases that are kind of very interesting are around collaborative applications. So enterprise kind of tend to use these collaborative applications to interact with your employees, with your documents, with your backends, and how we use AppSync to kind of streamline those real-time updates. And last but not least, which is the most interesting ones that we just ran into, was leveraging Amazon Connect. So Amazon Connect has a lot of personas, and customer persona only has just a handful of features available to it. How do we actually introduce generative AI capability to the customer persona? We'll talk about that. I'm going to spend like a few minutes on this particular slide, although I apologize that you can't see the arrows. I'll just kind of talk in terms of the numbers. This is the core fundamental aspect of our asynchronous architecture. When you start any kind of real-time updates, you need to subscribe first using a unique session ID. The session ID can be generated from the front end or in the middle tier if you want to take care of like duplicates and whatnot. For the sake of our demo, we chose to do it in the front end. When you subscribe, at the same time, imagine you're typing a message like, how do I reset the resolution of my monitor screen, right? That's a typical IT-related questions. That question will flow through into the back end, and your front end will invoke a query. The query operation is synchronous, and it will then land a message onto SNS. It can be an event bridge, it can be a database, any kind of intermediary placeholder which can trigger a next set of operations. So, and the query will return immediately to your front end. And at that point, it's up to you how you want to represent the UI. And you'll see in the demo how we choose to do this. You could show 3-dot animations for a fraction of a second until the token generation starts. Then comes the backend workflow. The backend workflow is asynchronous completely, and it will basically go and run either your typical RAG, which is retrieve augment generation workflow. You can run agentic workflows. In this case, in the Amazon Connect case, second part of the presentation, we will see how that RAG how that agentic workflow we can use as with AppSync. So then, when the token starts to form in Bedrock, the Lambda is actually invoking, by the way, invoke model with response stream API, not the typical invoke model API. As soon as the token starts forming, Lambda is going to actually start calling mutations, server-side mutations on your AppSync subscription, which will you have to use that unique ID to kind of call those subscription, because you don't want to cross wires. You only want to address who is this token meant for, right? So that's where this unique session ID comes into play. There'll be a better diagram in the next slide. Unfortunately, we didn't have time to kind of edit it at the end. But that's the general architecture. That's the core foundation of the two use cases. So now a little bit about the first one. This is an interesting one, and I'm pretty sure majority of you guys have kind of run into this or will run into this. In any large enterprise, we typically have guidelines, specific guidelines on how to communicate with your customer, how to communicate with your employees. So you would have content generation and tone analysis before that messaging goes out to your an employee. The challenge that the customer that we've been working with faced was exactly that. They were spending a lot of time editing these contents. They were spending a lot of money on third-party licensing applications. So we did an experiment using Bedrock and specifically Claude model, which our next speaker will talk a little bit more about. And we were able to kind of automate this whole content generation, tone guidance through a large language model. So you have to give it a bunch of instructions. The prompt can be bigger, but that's the solution that we came up with. So it doesn't only address the content analysis, but we're able to easily combine both REST and GraphQL together. Under the cover, there's a prompt management system, and you can augment this to a point where you can address any kind of business needs. So that's the value adds. Customer significant cost savings, but the real value was around automated analysis of language. You could do language scoring. You can do brand voice analysis. So imagine it's amazing for marketing folks who actually want to follow a certain set of guidelines before the communication goes out, right? So all of this is doable. So it's the same diagram, a little better this way. And I guess the surprise that I saved for later for this section was that we introduced Microsoft productivity applications into the mix. GraphQL and AppSync is very versatile, that you can basically inject any kind of front end in this with AppSync. So the concept here is that our backend infrastructure is the same, our Bedrock model is the same, but where the data is flying in is into the Microsoft applications, the productivity application. We'll talk a little bit about what those are. There's a concept of add-in. We added, an add-in is hosted internally within the enterprise, so securely using your own security guardrails. AppSync has the capability to do authentication and authorization using your own identity providers, and you'll see that in the next slide. And the nice thing about this add-in is that it will work across the board in all your Microsoft productivity apps. Just a little blurb on how do you do this. There's this thing called meta manifest file, and manifest file is sort of like your packaging structure for your add-in, and you specify where your actual application is sitting. Under the cover, it's a single page application, but you have to create the application with a certain set of SDKs so that it can interact with your document, it can interact with your spreadsheets, your email, and it's sort of like a built-in assistant, and of course it controls the look and feel of how the add-in appears. A couple of things on GraphQL schema. So the schema is very basic. Like I'm not going to dive too much deeper into this. If you have more questions, please come up to us and talk to us afterwards. At the core, you'll see mutations, query, and subscription. Query and subscriptions are used by the client, as we kind of talked about that foundational architecture. Mutations are used by your backend, right? So you're still using AppSync as a gateway to push your mutations out to the front end, even though your front end is not really your typical front end. It's an Office suite. And I think the more important things that I didn't highlight here is the resolver. So the resolver uses a specialized filter. It's a filter to ensure that you can the session ID that you pass in is captured, and you're sending the mutation to the right client, right? Because you don't want to crossfire, and you can add additional additional subscription filters inside the resolver to make sure from a security standpoint. That's a typical one that everybody uses. If you don't want, if you want to ensure that the user context is who you say you are, you want to typically add that as another subscription. Okay, so this leads us to the demo. All right, so I think this is pretty legible. So I have like a typical document here that, for example, your marketing folks are working on, or any other any kind of contents that you have, and under your ribbons, you typically have this add-on, and you can launch your own sort of add-in. And this is, there's a whole story behind why it's called Ruth. You know, we can talk afterwards. But basically, when it's rendered, you get an interface. So you can do things like summarization. You could do language scores. You could classify documents, and these are, again, these are very marketing specific, or the your department specific requirements. You can change it to be whatever you want it to be. So content analysis is kind of easy that way. So first of all, we're gonna do a quick demonstration of synchronous call. So this is a call that is going on behind the scene. It's taking the contents of the documents, submitting it through a query operation back to AppSync. Then it goes. There's a prompt that gets augmented behind the scene that says, okay, this is how you score this contents. Here are the brand guidelines, and then the query operation, and large language model kicks in, Claude specifically, and it will come back with a response. Again, this is serverless environment, so everything is cold right now. So you saw the real-time response coming back, and here you get some sort of an analysis. So you could see that the document has a lot of long sentences according to the guidelines that we had in the prompt. You can change that per your requirement. Passive voice uses a passive voice, and again, this is all changeable. The whole point of this demo is to kind of show you that you can use AppSync as a gateway to do content analysis and use a very different front end for all of that. So now I'm gonna quickly kind of show you just a couple of things that you can do. So we saw the synchronous invocation. I'm gonna do a subscription use case so that you could see how the real-time updates happen within the document. So let's do language translation. So Claude has the capability to translate into multiple languages. You can go back and forth between different languages as well. So let's translate, and I don't speak Chinese, but this will only translate the section highlighted in the document, and hopefully, if it comes back, show you in real time how the translation will work. I didn't choose to do the whole thing just because it's a pretty big document. But translation can happen, and you can go back and forth between a language that is in the document and back to English, for example. Okay, so this sort of concludes, like, there's a lot more features in here that I'm not going to go over in the interest of time. So let's go back to our presentation. Okay, so this kind of leads us to the second more interesting one. To me, it's more interesting because we spend a lot of time kind of analyzing this this particular challenge. So the challenge was Amazon Connect has this 8-second sort of timeout, very hard limit. You can't change it, and there's real reason for this. And the reason is that you don't want your customer who is waiting on the phone to be hanging there for too long, right? So any kind of real-time updates need to go to the user as quickly as possible. So there are timeouts that we encountered in Amazon Lex and Lambda. If you work with Connect, we'll kind of touch briefly on this. And then the backend API calls traditionally will take a lot more time to execute. And the challenge was, okay, my password resets, or I'm trying to check my ticket status information, my caller is waiting. How do I ensure that I can actually push that updates in real time to my end user and still not time them out? So the solution is kind of interesting. We use the real-time updates. We sort of like created a reusable SDK to handle these backend workflows, and the output was quite interesting. This solution is still going through closed beta within the customer environment, and our MTTR, mean time to resolution, kind of reduced significantly within that confined people of testers that we did. Obviously, it introduces 24/7 support, and the timeouts were gone, almost. A little premiere on what Amazon Connect is. It is our Amazon's way to do virtual data centers on the cloud. There's a lot of functionality available for agents. I don't know if you've seen an agent dashboard, but basically you have generative AI capability with Amazon Q built into the agent, so you can do sentiment analysis, you can do call analysis, you could also generate a lot of data. Like you could actually run a RAG with Amazon Q within the agent dashboard. Administrators have a lot more capability to configure. Supervisors can do analytics, for example. So there's Q Insights and all that is built in. Customer, however, as I said, is not a lot of functionality. So if you wanted, our goal was to kind of push this generative AI capability to the customer so that they can interact with the model in a more responsible way. So I'm going to spend another minute on this architecture. It may look a little too busy or daunting, but it's not. Fundamentally, it's the same. It covers that very basic architecture we talked about in the beginning. If we look at the diagram, the step 2, the user starts the interaction with the subscription and query, but step 2 is not really sending a message to SNS here. We are sending a message to Amazon Connect. And when you start a chat with Amazon Connect, it basically, you have an option to have Amazon Connect send real-time updates through an SNS topic. So you have to specify that during that call. And when Connect has some data available, it will push it back to the SNS topic, which can then go back to the bottom lambda that can call the mutations on the front end. So the fundamental architecture is the same. What's the interesting and different part is the top right corner, where inside the Amazon Connect flow, and we'll talk about it a little bit, when you trigger the flow, you have an option to capture the user's utterance or intent using Lex. So Lex has inherent problems, so we chose to just use Lex for capturing user questions or utterance, nothing else. So as soon as that is done, we get out of Lex. And then basically in the flow, we then go in and invoke a Lambda function to say, all right, now we need to kind of trigger our backend workflow to, we've got the utterance that this is how do I reset my monitor resolution. And now we want to go back to our knowledge base behind the scene to kind of look it up. Okay, what does that mean? So with that, we trigger that workflow. Lambda will basically go in, and you need like a session storage or a persistent storage in the middle that will serve as an intermediate layer, as I explained earlier, to trigger the backend workflow, so that while the backend is running, you're sending updates to this database in the middle, and you have a Lambda function sitting on the side that is checking constantly whether more updates are available from the workflow. So in that case, you can imagine you can send these status updates in real time to the person who's on the phone, waiting for a response. So here, exactly that's what's happening. Lambda will kind of go in and run the workflow, whether it's agent. In this case, we are going to use agentic workflows to kind of trigger your questions and queries using tools, right? A little bit about that workflow is that in Claude, and our next speaker will talk a little bit more about this chain of thinking, but just kind of briefly touching on the chain of thinking workflow, we equip the model with a set of tools, and those tools are, in this customer's case, were password reset, check my ServiceNow tickets, and go and search my knowledge base. So, customer has their own knowledge base behind the scene. So we equip the model with that. And the cool thing about Claude is that it can understand very complex queries, as we will kind of showcase in a second, where you can combine the questions together, and Claude will figure out, okay, what tool do I need to execute behind the scenes. So this is not happening using Bedrock Agent, by the way. It uses LangChain in the background, but the concept is the same as with Bedrock Agents. Okay, so again, I'm not going to spend too much time here. It's the same thing as the original. The only thing that I think I'm not showing here is the complex structure that comes back from Amazon Connect that is slightly different. But behind the scene, you have a query, you have a subscription that is used by the front end, and then a mutation that our Lambda will fire as it's getting the response from Amazon Connect. If you haven't seen the Connect flows before, they can get a little complicated, but typically, like, this is what a flow looks like. Our Lex is actually it's being used to capture the user's intent. And then on the next slide, where we are in the flow basically kind of circulates back and forth until it has a response from the backend. And the backend response is coming from the invoke status Lambda. It's constantly checking that database. Do I have an update? Do I have an update? And if I have an update, I'm going to push it back to the user. You can take a picture of this, and you can try it out on your own, but I'm going to quickly switch over to our demo. So we saw this one, and this is our interface. We're using a web application, and what's happening right now is that the chatbot is going in to do a handshake with Amazon Connect. And what comes back from there is that the flow has started, and it will respond back with, all right, how can I help you today? So we'll say that, can you reset my password? My username is SM110. So conversation history, you can add conversation history so that it becomes truly conversational, but I'm providing all the data in my question. If I don't, then, like, if I skip my username, it's going to come back to me and say, hey, what is your username? But conversational history is not kind of baked in at the moment. The whole point was to kind of showcase how to connect, how to bring Amazon Connect and the long-running workflow. What these fulfillment updates that you're seeing are coming back from Connect directly. Specifically, the thought process that goes behind the scene on how the bot selects the right tool is also kind of streamed back to the front end, right? And then when we ask a more interesting question, so can you reset my password and check my ticket status? My username is SM20, and my ticket number is ABC123, something like that. So now you will see Claude will go and identify the question, this utterance, as a multi-step process. And it will try to determine the right tool to first reset your password, and then it will, all while the long-running workflow is happening. If you didn't have the long-running workflow, this would have, we would see timeouts. So you can see that the Claude thinks that, okay, now I need to check my ticket status, so I'm going to use this tool. And finally, the reset and the password, and it kind of nicely combines the output together. Feel free to experiment with this on your own in that slide. I'm going to go back to our presentation to let you take a picture. There's a voice demo phone number as well. Feel free to dial that in, and you're going to interact with the generative AI voices behind the scene that kind of power the engine. And with that, sorry. Oops. So I'm going to actually, to kind of dive deeper into these LLM prompts, I'm going to ask Kyle from Anthropic to help you. All right, thank you, man.
Thank you.
Right on time.
All right, so as I was getting to know Brees and Solomon, and we were talking about their use case and kind of figuring out how we could collaborate on a talk, we were going deeper, and as they kind of told me the behind the scenes of what it took to build these things, I heard a lot of common themes and common challenges that I see with other customers. And so I thought it'd be great to end this presentation talking about 5 common challenges you might run into building on top of LLMs. So my name is Kyle Rube. I'm a member of the Applied AI team at Anthropic, and I work with our customers from pre-seed startups to Fortune 500s, build amazing products and features on top of Claude. So the first thing you might run into and have to think about is, okay, there's a lot of LLMs out there. There's more coming out every month. How do I pick one to power my product? And if you go on Bedrock today, there's over 30 LLMs that spit out text. There's, of course, other LLMs you might be considering that are not available in Bedrock. And how do we narrow down that list? The first thing we can do is there's a whole bunch of public leaderboards, benchmarks out there that we can look at to kind of get a pulse check of what's going on. One anecdote about this I'd like to share, though, is that, for instance, Anthropic today has a model called 3.5 Sonnet that is considered by many to be the best coding model in the world. However, if you look at some of these benchmarks and leaderboards that measure coding, Sonnet is not at the top of all these lists. So if you were to just look at these benchmarks, leaderboards, and just pick what's ever at the top, you might be missing out. Sometimes these benchmarks are missing some of the nuance that is specific to your task, your data. So use these to kind of narrow the list, but then we can do some other things as well. Of course, if up front you have some very obvious price or latency requirements that are non-negotiable, these are things you can kind of model out, benchmark on your own, and kind of disqualify some models. If that's not an issue, I tend to recommend that if you're looking at a bunch of models, that you should use the best models available to you, particularly if you're building something that is new and experimental, and you want to prove out value to your customers, to stakeholders, make sure you have some product market fit. And then down the road, treat moving to the faster, cheaper, smaller model as more of an optimization exercise. And then the last thing here is when we're thinking about selecting models, and I'll talk about this a little later on, is this is where it starts to really matter having an evaluation strategy for your task, thinking about how you actually are going to measure the performance of your task, and you can start to compare models head to head. This also matters after you've shipped something and new models come out. Do you know if that new model is going to be better for you and you should replace whatever you've built? Quick overview on Anthropic, what we have today when it comes to models that you might consider if you're going to build on top of Claude. The model that probably you should look at first is Claude 3.5 Sonnet. And there's 2 versions of this, one that came out earlier this summer and one that came out more recently in October. I'd recommend grabbing the October one. It's a little better just across the board. And this is going to be our most intelligent model right now. And it's going to be particularly strong in things like software engineering. It's also going to have great visual abilities, so it can consume images and reason over the images. It's going to do your basic stuff like writing, all your kind of standard sort of LM tasks you might throw at it. And then on top of that, this is the first model we've released that can do something we're calling computer use, where we've actually taught the model to navigate a computer just like you would. The idea here is we give the model some basic tools, a mouse, a keyboard, and basically the ability to grab screenshots. And the model gets to decide how, based on the screenshot, where it moves its mouse, where it clicks, where it types, and all that. The other model that is worth pointing out, I'm going to touch on quickly, is Claude 3 Opus. This is a model that came out this spring. And at the time was our most powerful model, but as we started to refresh our model family with 3.5, Claude 3 Opus hasn't been refreshed yet, and so I would tend to recommend staying away from it. use 3.5 Sonnet. We do have customers that use Opus in production, but it tends to be more rare, and I would try Sonnet first. And then we also have 3.5 Haiku. And the idea with Haiku is, can we take everything that makes our bigger, more powerful models great, the coding ability, and try to package it up into a smaller, cheaper model. Smaller, cheaper, faster model. And so when speed matters, you're going to be looking at Haiku. It's still going to be great at coding, but especially stuff that's very real-time. Haiku is quite nice. So the next challenge is, once we have a model or a set of models, we also need a prompt. And here's kind of my thoughts on prompting going into 2025. The first thing is that as new models come out, they tend to become more steerable. And what that means is that prompting becomes increasingly intuitive and accessible. So when I joined Anthropic, I spent a lot of time working on top of Claude 2. And Claude 2, you might spend a whole afternoon just trying to tease out anything useful by tweaking the prompt quite a bit. Today, you can spend 5 minutes writing a prompt and probably get some pretty good outputs out of our newer models. That said, I'm going to talk about this, but there's a few prompting techniques that I'm calling timeless, but probably are still going to matter in 2025. And the last thing is my belief that more prompts are going to be created or with the help of what we call meta prompting tools. The idea here is, earlier this year, we realized that Claude is actually quite good at prompt engineering itself. And so we built a system that can create and improve prompts. And of course, a lot of other companies now are creating similar things. So let's talk about some prompting techniques that still matter. The first one, and this isn't crazy or anything like that, is we should be clear and direct. One of the main things I do with customers is they pull me in and I ask them to see their prompts, and they show them to me, and my job usually comes down to reading the prompt and finding things that are vague, ambiguous, don't really make sense, and then I can go back to the customer and say, hey, what do you mean by this? This doesn't make sense. Because if it doesn't make sense to me, it's probably not going to make sense to the model. And so we call this the golden rule of clear prompting. When you're writing a prompt, think about this or actually do it. Take your prompt, give it to a colleague that maybe doesn't know exactly what you're working on, and say, hey, if I gave you these instructions, could you do this task? If they say yes, probably the model's going to be able to do it. If they say no, maybe you should go back and work on the prompt a little more. On top of being clear and direct, it does help to have some prompt structure. And so on the right here, it's a little small. This is a prompt that came out of our meta prompter. It's kind of a toy example. It would be like travel itinerary sort of thing, take some user inputs, generate a travel itinerary for them. And what we see come out of our meta prompter is a few things when it comes to structure. The first is using 1 to 2 sentences up front, super high level, roll what the task is. Hey, Claude, you're an AI travel assistant. Your task is given some user input, output a travel itinerary based on the instructions below. Then if we're doing any sort of dynamic content, if you're doing RAG, you're pulling a bunch of help center articles, do that next. Then follow with our instructions. Here the meta prompter chose to kind of do it in a numbered list. I like this, but very crisp, short. And then if we're doing things, which I'll talk about later on, things like examples, we're going to ask the model to do some chain of thought. We can finish with that. And then one prompting trick I like to use is, if Claude is forgetting to do something or it's not doing an instruction very well, you can repeat that instruction at the very end. That tends to be quite effective if Claude's just being kind of difficult to work with. So let's talk a little bit about using examples. Using examples is probably the most powerful prompting technique we have to getting Claude to do what we want it to do. And the reason for this is, a lot of tasks, you could spend a lot of instructions trying to describe to Claude what a good output looks like. But sometimes it's easier just to show Claude. So particularly if it's something around style or tone, it's a lot easier just to show Claude 10 examples of what really good outputs look like, and rely on Claude's ability to generalize and infer what the instructions are, versus trying to write it all out yourself, which can be a little vague. The other thing about examples is, when we add examples to our prompt, of course, that means we're increasing the size of the prompt or adding input tokens. And that does have an impact on things like latency and cost. However, as far as tokens go, input tokens are quite a bit cheaper than output tokens. And so we can add quite a few examples and make our prompt quite a bit longer, having marginal effects on our latency and our cost. The other prompting technique I want to talk about is having Claude output tokens before its final answer, or what might be kind of considered chain of thought. Basically, we're letting Claude kind of think out loud or do some work before it says, hey, here's my final thoughts. And then you take all those kind of early tokens, you just throw them away, you don't show them to the end user, and you just use the final output. And typically, this tends to improve answer quality. Now, this has a bigger trade-off, which is output tokens, kind of like I hinted at, are more expensive, and it's also a little slower. So for some use cases, this might not make sense, but it's quite powerful. It's also fun to use for debugging. You can actually read the chain of thought traces yourself, kind of try to get in the head of the model and be like, okay, why is Claude doing something dumb? You can read the chain of thought and try to debug and then go fix your prompt. Okay, so I talked a little bit about latency. Of course, if you're building on top of LLMs, these APIs tend to have higher latency than you're used to. So if you're building a lot and you're used to like 100 milliseconds and all of a sudden you're using LLMs and you're getting responses in 2 seconds, 10 seconds, 40 seconds, that can be a little weird and have real kind of product implications. So one of the best things we can do to solve this problem, if we can, is instead of kind of waiting for the API to respond with the whole kind of output at once, we can instead stream our outputs. And what's great about this is if your product supports it and it makes sense, your end user can start seeing stuff right away, and the response will actually stream in faster than most people can read. And so a response that might take 40 seconds to fully complete, I can be reading it as it comes out. Now, what else can we do around latency? Of course, one of the best things we can do is use a faster model. Faster model tends to mean dumber model. So if you're on Sonnet and you're trying to get down to haiku, that might mean if you're trying to hold accuracy at about the same, you might have to spend a lot more time on prompt engineering to make that possible. I talked about this a little bit, but when we talk about end-to-end latency, the number of output tokens matters quite a bit. So can we maybe remove the chain of thought that was originally working and use examples instead? Maybe Claude's being too chatty. Can we ask it to be more concise? Is there anything we can remove in the outputs to make our output shorter, which will improve end-to-end latency? There's other features we're working on to kind of like supplement the model around inference. One of those is prompt caching. This is something that's coming soon to Bedrock, which is this idea where if we have a lot of prompts that are all kind of the same shape, we can do some optimizations on our side, which will kind of let us kind of pre-process a lot of input tokens and kind of cache results, which ends up with latency improvements. And then the last thing you might consider doing is reducing the number of input tokens or making your prompt shorter. Now, I only bring this up, and this is only useful when you have a lot of input tokens and you have an option to shave off thousands and thousands of tokens from your prompt. So maybe you have some sort of RAG thing where you're pulling in a bunch of Help Center articles. If instead of pulling in 20 Help Center articles and you're pulling in 10, that's pretty interesting. If you're trying to shave off like one sentence from your prompt, you're probably not going to see any impacts on latency. Claude consumes input tokens really fast. It's not going to matter. Another thing that a lot of teams come to me and they say, hey, Cal, I love using Claude. It's really cool, but we can't use it because you don't have JSON mode. And our LLM is part of some sort of back-end process, and we really need Claude to just output JSON. I work with a lot of teams like this, and rest assured, there are techniques, even though we don't have a formal JSON mode yet, to get very consistent, high-quality structured data out of Claude. So I'm going to talk about a few of them. One, and it goes back to our prompt engineering, we just need to provide clear, detailed instructions describing to Claude what we want. And Claude 3 and above has been trained to be quite good at outputting JSON. We might need to add an instruction like do not include a preamble or postamble. Claude loves to say things like, yeah, sure, here's your JSON, and then it'll spit out the JSON, and then you got to kind of parse it out. It's annoying. Also, we can use examples. Hey, Claude, here's what some good outputs look like. Make sure it's the JSON that we want. And then if those two things don't work, and usually this is enough, there are some advanced techniques we can lay in. We can try to use things like tool use, which is a great way to get structured data out of Claude, and we can kind of make our JSON outputs fit to a tool and do it that way. There's also things like pre-filling or putting words in Claude's mouth that get us some pretty good results. The last thing I want to talk about is how to evaluate your LLM feature. And so this is a common problem that just about everyone is going to run into, or everyone is going to run into. And the idea here is LLMs are probabilistic. And you're going to make a change to your prompt, or you're going to change your model, and you're going to ask yourself, how do I know if I made things better, worse, or about the same? And so the way you evaluate, or your evals, determines how quickly and confidently you can iterate on your LLM-powered product. So I'm going to talk, and this is super deep. There's probably a bunch of other sessions throughout the week on this topic. I'm going to talk about what I kind of see as the 5 kind of categories of evals, and some general thoughts on them. So the first way you can evaluate is what's kind of, I don't know, jokingly called evaluation by vibes. And the idea here is as you're working on your prompt, you're just kind of testing it as you go. Maybe you have 5, 10, 20 kind of example things you like to throw into your prompt and see how things are going. And you're sort of making a mental note of if you feel like you're making good progress. And this is great. A lot of projects start with vibes. There's no setup required. You have very fast, very tight iteration cycles. However, there's some pretty clear cons here. One is that we lack any sort of quantitative rigor. We can't really assign a number to how we feel the vibes are. It doesn't really transfer well to teammates. They might not be getting the same vibes as you. They might have different test cases than you, and you're sort of flying blind. But a lot of projects start here. A lot of prompt engineering. You might do a little bit based on vibes, then do other things, and you could argue something like hosting internal bug bashes vibes at scale. So what else can we do? What are some alternatives? We can do various things with humans. So one thing you could do is we could kind of up-level our vibes eval, and we could actually go define a bunch of test cases. And then we could also take the step of not just getting test cases, but also creating a well-defined rubric. And so then when we update our prompt, we have our test cases, we run it against the prompt, and then we grade all the outputs against the rubric. Now we have this nice quantitative grading. We have human in the loop, so we really trust the outputs. We feel good about it. But the con here is that it can be, the grading can be slow. It can be expensive, particularly, I don't know, if you work in some sort of trusted field and the grader needs to be a lawyer. That can really slow down your iteration. Another thing you could do is you could maybe improve your prompt based on vibes and then put it in production and see how end users react to it. So I work with a lot of teams that, as part of their evaluation strategy, they A/B test. And what's great about A/B testing is, of course, you're measuring what ultimately you're trying to change. I don't know, we put a new prompt in and daily active users go up, checkouts increase, whatever it might be. The problem I see with A/B tests is the iteration cycle is quite slow. You got to put your test out there. Maybe it takes a week to get results. You got to interpret them, and then maybe you go back to the drawing board. It can also be hard to interpret why downstream metrics move based on prompt changes. Wow, I made a prompt change and this metric went up, that one went down. I don't really understand why. So what else can we do? We can do evaluation by computers. And so there's deterministic checks, or what I might call programmatic checks. The idea here is we do evaluation by code. So we still create a test set and we write code to kind of grade our outputs. And so this works for some things like exact string matching, regex. There's things like semantic similarity against golden outputs. And this allows for very fast, very tight iteration cycles. You write a new prompt, you run your checks on it, you get a score, a couple scores, you know if things are improving or getting worse. Works well for things like classification. But of course, it can be hard for some tasks, like, I don't know, you're building a chat bot, you're building something that requires some creative writing. It can be hard to capture the nuance of that task in code. And so the last alternative here that teams are looking at right now is this idea of LM as judge. So instead of having our humans with the rubric grade our outputs, we try to write a prompt with a similar rubric or the same rubric and have the LM do it instead. And so now we get to keep our fast iteration cycles. This is all programmatic. We can apply it to a wider range of tasks. But this is also quite tricky because this only works if you're able to kind of align the LLM and how it judges with how a human would. If the LLM's doing something completely different, not the most reliable signal. So what I've seen that works well is how you choose to evaluate depends on your business goals. And it's typically probably a blend of those kind of 5 categories I talked about. And prompt engineering and working on LLM features and products is an iterative process. So when we think about evals, having something or having a process that lets us move quickly and iterate will help you move faster and get your products into production. So with that, we are at time. I'd like to thank everyone for coming. We will be hanging out over there if you'd like to come by and say hello, ask us any questions. Thank you very much.